Hi, welcome to this podcast. In this podcast, we'll be covering Access Anywhere, which is VPLEX's unique distributed cache coherence technology. My name is Ashish Pelekar. I lead the VPLEX product management team. So what is Access Anywhere? Access Anywhere is VPLEX's unique distributed cache coherence technology. It's the secret sauce that makes VPLEX stick. It's what allows VPLEX to present a consistent image of data from multiple sites. As we discuss this with customers, one of the questions I often get is, how does it do this? How does the same data get presented out of multiple sites? Hopefully this podcast will help you understand how VPLEX accomplishes this. There's 3 scenarios that we'll walk through, each one building on top of each other. The first is a local VPLEX cluster. We have the same volume presented out of multiple ports on a given VPLEX cluster. In that scenario, how does the same data get presented? The next scenario is you now have actually 2 VPLEX clusters and the same volume being presented out both those VPLEX clusters. How does that work within metro latencies, so up to 5 milliseconds round trip time? And finally, the third case is these 2 clusters are now spread further apart up to geo latencies, so up to 50 milliseconds round trip time, and how does Access Anywhere work at those latencies? Before we delve further into each of these scenarios, some concepts. There's 2 ways to actually share data and make sure that there's consistency maintained at the data level. The first method is through locking, right? You can lock blocks, you can lock objects, and present that same data out. That'll give you consistent data. It works, but it doesn't scale. It doesn't scale across multiple nodes, and definitely doesn't scale across distances. As anyone who's worked with clustering technology knows, the whole act of reserving block spaces is not tenable as you start dealing with a large number of objects. The second way of actually accomplishing this is doing some work as the data is received. You can now take that data and keep a record of who has access to that data. It's almost pre-hashing the data, if you will. We call this the Global Cache Coherency Directory, which is shared by all directors across VPLEX. So you have a record of who has the latest copy of that data, and it's what makes Access Anywhere tick. So without further ado, let's jump into the first scenario, which is a local VPLEX cluster and the same volume being shared across multiple directors. Some terminologies. The basic building block for a VPLEX is what we call an engine. Each engine has up to 2 directors. For the purposes of this discussion, let's assume that the 2 directors are spread across different engines, but it really doesn't matter, right? So this is the VPLEX cluster. And I'm just going to draw 2 directors, director A, and let's do director B. I have the same volume, and I'm just going to draw a common volume that's presented across both these directors. And just for tracking this, this is the cache coherency directory. Okay. So what are the scenarios in this case? Let's make the assumption, or let's walk through a couple of scenarios. The first is a host does a write on director A. In this scenario, director A will first do a check locally and say, do I have access to this block from this host? The answer is no. It will then do a check on the global cache coherency directory and say, does anyone else have it? The answer is no. In that case, it will claim that block, and the global cache coherency directory will record the fact that A has access to that latest block. Now, local volumes are synchronous volumes, and as a result, the data will immediately get flushed to the backend, and the host will receive an acknowledgement after the write is actually written on the backend. Let's look at the scenario that same block is now accessed through director B. Let's walk through that same algorithm again. Director B is going to check its cache and say, Do I have it? Answer is no. It will then say, does anyone else have it? It'll go check the global cache coherency directory and says, aha, A actually has it. And therefore, it now goes and says, let me fetch that data from the cache of A and return it back to the host. So what has just happened? You have the same volume being presented from two different directors. One director has done a write on that volume, and that same block is now successfully returned, consistently returned back from director B. That's how Access Anywhere works at the local cluster level. Let's now play this tape a little forward and look at two clusters at synchronous latencies, right? So this is up to 5 milliseconds round trip time for the purposes of this discussion. Just like before, I'll just record one director over here, right, to illustrate the case, and it's called this director C. Now this cache coherency directory is actually now shared across the two clusters in a VPLEX metro, right? This config is what we call a VPLEX metro. And for the purpose of this discussion, that same volume V is now presented across A, B, and C. Just so you folks have a visual representation of what this actually looks like, you're fundamentally stretching that volume V, right? With Access Anywhere, you're now able to stretch that volume V. It's the same identifier now being presented across multiple locations. Let's run through that scenario again. So host does a write on the director A. It says, does anybody have it? Let's say we are starting from scratch. It says, I don't have it. Does anybody have it in the global directory? Nobody else has it. Therefore, it says, aha, I'll claim it. I'll record it in my cache and write it to the backend. Remember, we're still talking about synchronous volumes over here. Now, the same block gets read from director C. Let's walk through that logic again. Do I have it? No. Does anyone else have it in the global cache coherency directory? Aha, A has it. At that point, C has a choice. C can either fetch it from A, or because it's a distributed volume, which means it has a local copy, it can fetch it from the backend. You have the option of tweaking that as an option. Typically, the cost of going across the wire is more than the cost of fetching it from the backend, right? So VPLEX is actually smart enough to figure out A is actually on a different cluster and far away from me. Therefore, C will actually go and fetch it from its backend, right? So it will actually fetch it from its disk and keep a record of it. Again, what has happened? The same consistent data for a volume is now returned from multiple locations. They happen to be separated by synchronous latencies. Pretty cool stuff. Let's go through the next iteration of this. Now imagine these clusters are at asynchronous latencies. We're talking about VPLEX Geo, so up to 50 milliseconds round trip time. I will skip the first part because the first part is write comes into A checks locally and says, do I have it? Says it doesn't. Goes and checks the global cache coherency directory and says, does anyone else have it? The answer is no, and therefore it does the same stuff. There's an important difference though. Because this is an asynchronous, this is at asynchronous latencies, it doesn't automatically flush to disk, right? The whole concept of asynchronous is we now return the write to the host, acknowledge the write to the host before it's flushed to the disk. So to make things interesting, let's assume that that flush of the disk has not happened. In other words, it's in the cache for director A, and a record of it is in the global cache coherency directory around who else has it. Now things get interesting, right? So the read comes into director C, and the same question gets asked. Do I have it? The answer is no. Does anyone else have it? The answer is yes. In this case, A has it. Now, we go back to the same question we had in the metro scenario. It knows that that data is dirty, right? So as part of checking on A, it says, is this dirty or has this been flushed, right? Because with asynchronous, it has this option. In this case, it knows that that data has not been flushed. And therefore, it has no choice but to actually go and say, fetch me that data from director A. In other words, return me a consistent copy of that data, right? So it will fetch that data from director A, make a record of it on the local cache, and return that data back to the host. Again, what has happened? At asynchronous latencies, we have now got the same data being presented for the same volume out of multiple locations. The important thing to remember is that periodically, this data from the cache is actually going to get flushed to disk, and it gets flushed on both sides. So a large majority of the time, you're not, in fact, going from one cache to another, but are actually getting the benefits of site local access to that volume. That is how VPLEX Access Anywhere provides you the benefit of consistent data within a local cluster, within 2 clusters at synchronous distances, and up to 2 clusters at asynchronous distances. That is the power of Access Anywhere. That's how Access Anywhere is able to give a consistent data image, whether it's in a local cluster, at synchronous latencies, or at asynchronous latencies. Hope this was useful. Thank you.